All right, we are wrapping up streams with one last video. Video page 10. I'm sorry, 12. I misspoke. It's got to be video 8 now, right? Top of your page, there's something looking like this. So, what happens to particle size and why as I go that away? Okay, so I see the stream, I see the ocean, and I see bedrock. Okay, the stream is going into the ocean and depositing. Okay. What happens is particle size, it decreases because the velocity decreases. So I'm trying to see if we're writing that anywhere. And I don't see a good spot to write that. There's other things underneath this. The 1, 2, 3, 4, 5, 6 is not where you're writing that. So maybe on the left-hand side of this picture, you're writing that. Okay. And then here we go. One is sorted and round sediments. And one of the things you need to be able to tell me is that underneath area A, right, is going to be cobbles and boulders. I'm not sure if that's going to just show up, but fishies love sedimentary rocks. There we go, cobbles and boulders. So underneath that picture, you're writing cobbles and boulders. The big stuff is going to stop first, okay? Area B is pebbles. And both of these two things, cobbles and pebbles, cobbles, boulders, and pebbles, all come into what's called breccias or conglomerates. So in the actual picture, I want you to get those words in on their proper places and then draw that thing down and get that in above where the 1 is. Because with the 1, you're actually going to write sorted and round sediments. And then this is where they're showing up in the picture. So sorted and round sediments are going to be in areas A and B. That consists of cobbles and boulders and pebbles. Notice the pebbles are smaller, so they're going to go farther. You can see their sizes here. And the sizes have to do with what we did last page, where it talks about particle diameter, and you see the same numbers here, right? 0.2, 0.006, 0.004. These are what's on your the chart on the previous page. Okay, so now we're making sense of it. Area C is going to get sand, and that's going to turn into sandstone. Okay, the pressure of the water is going to turn it, and silt is going to turn into siltstone. This is nice. And then the last piece is clay, and clay is going to turn into shale. Good. So that's what you got to get in just the picture. Okay. The sand with an arrow down to siltstone, right? Silt to siltstone, clay to shale. And there's enough room in between the picture and the 1 to get the breccia conglomerates, the sandstone, the siltstone, and the shale written. Okay, so you can get that all in there. And then some pictures to see how this is going. Ready? Always dependent on water velocity. So slow, fast, slow, fast. You can, graded bedding, where the water's moving slow and where the water's moving fast. And you can see the different speeds here of the water flow in the rock, right? Because you can see the different sizes of stuff. It's definitely banded. Check this bad boy out. This is a stream that you can tell was windier. Okay. Those loops, it used to loop and then it eventually cuts off the loop. So isn't that pretty cool? That's a really neat looking waterway that's changed a lot over time. So that's called an oxbow lake. Oh no, you can't see it under my face. Here, let me move my face. Oxbow Lakes, meanders that cut off have been cut off. So this is number 2. Number 1 was sorted and rounded sediments. Number 2, Oxbow Lakes, a meander that has been cut off, and then wide floodplain is what you're going to write next. 3 is wide floodplains. Meandering stream is going to have wide floodplains. Then the delta. For delta, we have fan-shaped, so it spreads out, finger-like, sorted sediments, example, the Nile River Delta. Okay. You can also write fertile soil. Okay, it's going to be very, very fertile soil, and it's going to go, the sediments are always going to go large to small. There's another example picture of what's looking, and those are some really wide floodplains. Like if the river floods, it's going to spread out a lot. And the drainage patterns. Oh, 5, fertile soil. So, I mean, the water is there helping the plants grow, right? The soil is pretty fertile. And then we have drainage patterns. And the reason why all these pictures are here is because it's dictated by topography, like what is the lay of the land, so to speak. Water always flows downhill, high elevation to low elevation. That should come pretty naturally to everybody. That water is going to flow downhill. It can never go uphill. Gravity is just too strong. Okay? With that, that should be the notes for streams. We are now done with streams. There's practice problems on the next page. You need to do those. And I'm going to save landscapes and bedrock for next week.